Good morning and good afternoon or good evening. Thank you for taking time out of your busy schedule today to come to another Crank Software Advanced User Training session on Storyboard, our embedded GUI software development tool. So today's topic, of course, is really expanding your ability to leverage other different type of image formats and really helping improve upon the memory requirements of developing a GUI application using Storyboard, leveraging the image loader plugins. So today, how can you participate? So definitely, if you're having any audio issues, make sure you check your audio settings or try refreshing your window because we are broadcasting over the web. We will have a Q&A at the end of today's session, so please feel free to submit any questions that you have, and we'll get to them at the end. Also, if you want to kind of follow along with Crank Software, if you haven't already, we are very active on social. So whether it's LinkedIn, Twitter, and Facebook. And if there's anything you want to kind of share out there, make sure you're using Crank Storyboard, hashtag Crank Storyboard, or hashtag embedded GUI development. And if you tag it in, we'll make sure that we amplify it as well. We're lucky enough today to have Jonah Quist, who is a product developer for our Storyboard product and very knowledgeable when it comes to the different image formats that are supported within Crank Storyboard. And so today's agenda, we're going to give you a little brief intro into Storyboard, just in case maybe this is your first time, you're relatively new, someone asked you to join, or maybe you came across it on the web. And then we're going to kind of jump into what are image loader plugins and how they can be used in GUI development within Storyboard. And then we're going to kind of jump into a sneak peek into Storyboard 7.0 and some of the new enhancements that have been made to the image loader plugins. And of course, 7.0, we're getting ready to launch that around the end of February. And then we'll talk about creating your own custom image loader plugins. So in case there's some unique image format that you want to support within your GUI application, that you can build your own to make sure that you can kind of leverage those. And then we'll jump into the Q&A portion of today's session. So let's jump in. So in case you're relatively new, what makes Storyboard different is that Storyboard provides a foundation for really kind of streamlining GUI development for embedded products that really meets the needs of both the UI development team, so whether you're a designer or an engineer, as well as the business goals. And it does this because it really decouples the front-end UI from the back-end logic and allowing the two to kind of be done in tandem. So without kind of taking away from what each other's working towards. And it does this by having a well-defined data model and event API that's in between that really provides the glue between the logic. So this clean separation between UI and development and hardware deployment really helps the UI design to be a little bit more resilient to changes. So whether those changes are design changes in the way the UI look, touch, and feel is, or maybe it's technology changes in the back end so switching from one particular hardware platform to another, or maybe one silicone vendor to another, or OS type. So maybe you're going from a FreeRTOS to a Linux or vice versa. So it really provides that. And the reason why is because we're not a code generation framework, making the UI development not reliant on hardware or coding changes in the background to begin in order to really kind of begin the UI development process. And of course, there are several unique features that make Storyboard different, such being the re-import feature. So the ability that any kind of files that were created in Photoshop or Sketch that were imported and became the building blocks for the UI, changes can be made to those files and then re-imported into the tool. And using our compare and merge tool really allows you to kind of go through and remain in control of what changes you want to implement. But more beautifully is that the coding events that went on, so the actions and events that were tagged to those UI building blocks are not disruptive. So you can easily make changes and still have the events and actions that were tagged to them or programmed into them using Lua scripting still remain intact. So it really allows for the UI to be refined at any point during the development process without really kind of disrupting prior work. And Crank Software is also a services company. So if you have a need for prototype development, for proof of concept with key stakeholders, or maybe you have an idea but not the in-house resources to produce it, or maybe you're even looking for ways to optimize the performance of the GUI application that you built using Storyboard, no matter what your needs or what you're trying to create, we have a team of storyboard designers and application developers that are really here to make your embedded project easier. So we can help you from start to finish, from planning, implementation, maintenance of your GUI application, or placing it through rigorous testing to uncover any issues that could impact the performance of your product. So just in case you weren't aware, we do have a professional services team that are here to assist where and when required. Also, if you're new to us, we have a help center and support. So we have a variety of getting started videos ranging from the very beginning all the way to testing and deployment. We have a series of knowledge-based articles really kind of diving into unique characteristics of Storyboard and really helping you kind of get the best that you can. So if you haven't gone and visited our help center, I highly recommend that you do. We also have a support community, and so it's there for you to pose questions to other people out there that are using Storyboard that maybe have come across a certain kind of building hurdle within the GUI development that you can pose a question. So whether it's us answering it or whether it's your peers answering it, feel free to kind of check it out. And so, okay, with that being said, I'm going to pass things over to Jonah, who is going to jump into today's topic, of course, which is using image loader plugins to really develop Storyboard applications in unique scenarios.
Thanks, Scott. I'll just get my screen sharing here. Okay, so, all right. Well, like Scott said, my name's Jonah. I'm a product developer for Storyboard, and I mostly work on graphics and things like that in our Storyboard engine. So I'm pretty familiar with our image loading plugins and leveraging them to get the most out of your application. So I'll just quickly go over what images are and what they do within the engine. Images are a pretty fundamental part of any UI. They're leveraged in Storyboard through the image render extension. It's a core part of the engine. We handle scaling and rotation within our resource manager in the engine. Everything's efficiently cached and optimized, and our drawing's efficient. It's just a mem copy on software render platforms. It's a texture quad on GL, and it's backed by hardware acceleration on MCUs where that's possible. So, and as for plugins, our engine's built to be modular, so most of the functionality lives inside plugins, which are stored inside your SB plugins directory, which you set during your engine setup. So you only need to take what you need. You can opt out of what you don't. Because almost everything is a plugin, you can get huge memory savings by taking out what you don't need. Common things that people opt out of are the audio plugin, the canvas drawing API, the touchscreen plugin, things like that. And the way that you opt out of a plugin is just remove it from your SB plugins directory, and the engine will work fine without most of them. The only plugin that you absolutely need to run the engine is a render manager of some sort, because otherwise you won't have a screen to draw to. Okay, so the engine supports several built-in image formats. Most of the common ones are supported, so GIF, TGA, JPEG, PNG, and most of them are supported through our Soil plugin. Soil is an image loading library that's built for OpenGL, but it works on software render platforms too. So you'll find that most of our image loaders exist in the plugins directory, and they'll be named Legere-plugin-sbimage- and then the name of the format or the library that they leverage. So like I said, the Soil one covers most image formats. There's also new in 7.0. There's a PNG specific one that leverages libpng. So if you're only using PNG images in your application, you can just use that one and remove the other ones. Or if you're using PNGs that use some fancier formats like 1-bit paletted and such, sometimes the Soil library can have some issues loading those. So you might find that you have better luck with the PNG plugin. And the other one that we ship right now, or that we're shipping new in 7.0 rather, is the SVG plugin, which is for loading SVG images that were exported from Designer, because we don't render the SVG images dynamically at runtime. Rather, we pre-rasterize them in Designer based on the content of your application model, and then just load the rasterized copy at runtime so that we don't have to pay for the expensive rasterization optimization, or rasterization process, rather. So just as a quick overview of how the image loaders work, they're swappable plugins. So what they do is they communicate with an API that's internal to the storyboard engine called SBImage. And SBImage basically just hands a struct to the plugin and says, put your image data in here. And then the image loader plugin does that and it gives it back to SBImage. It doesn't have to interface with the file system at all. So it's fully portable to MCUs that don't have a real file system or use a virtual file system. And yeah, so they're all completely interchangeable because they use the same API and they're all portable to all deployments of the engine. All right, so I'm going to go over how to create a custom image loader plugin. Just as a note that you will need SDK access to follow along with this, and that's just something that you would have purchased as part of your Storyboard licensing. And just a quick note that in order for your plugins to be picked up by the engine, they have to be in your plugin path. They have to have -plugin- in the file name, and there's certain symbols that they have to export to be picked up by the engine. I'll go over that when we get to that. All right, so I will just open my VS Code here. So this file that I'm looking at right now is sbimage.h. It's part of the Storyboard SDK, and this is what's going to kind of tell you what you need to do to interface with the SBImage API. We have our error codes and supported formats and things here, but the real meatiness of what we're looking at is this SBImage T struct here. So this is what you're going to need to fill in order to pass an image back to the engine in a format that it can use. So we have here, this would be a buffer that you allocate and stash your data in, width, height, stride, just general things for rendering. And then down here is the loader spec, which is basically just a struct that has 2 function pointers in it. And it's all explained in the comments of the SDK. And that's pretty much all we need to look at from there. So for our example today, I'm going to be showing a custom image loader plugin that I've written that uses the Turbo JPEG library to load JPEG images. So here are the 2 API functions that we would be using to interface with SBImage, the test and the load. So what test does is basically it just receives a block of memory from the engine that has an opened image in it, and then it has to return 1 if it can open it and 0 if it can't. And the way that SBImage works is it'll just walk down the list of every loader it has registered with it and test every image until it finds one that can answer it, or that can load it rather. And if it finds one that can load it, it'll load it, and if it can't, it throws an error. And then here's the load callback, which is what SBImage will call if the loader says it can handle it. Most of what's going on in here is just specific stuff to using the Turbo JPEG library. Really the important part is here you can see on these lines, we're filling in the SBImage T struct, which is passed as output. So this is the bare minimum number of fields that you'll need to fill in, width, height, and data, and bytes per pixel. So if you need to fill in 1 of bytes per pixel or the stride field, or the engine doesn't know how big your pixels are. And since this example is just for like a specific deployment, let's say, I'm assuming that we're going to be outputting in the RGB A888 format, but that may not necessarily be the case. In our plugins that we ship as part of the engine, we switch what format we're decoding into based on the render format of the engine, but that's something that you'll have to consider based on where you're deploying. And then here, we're just filling in the struct for the loader. And then this stuff down here is specific to creating the plugin. So this isn't specific to image loaders. This is any plugin that you write for the engine is going to have to export these functions and fill in this grcreate plugin API. So the first one, we're just calling, this is init, so this is called right after the plugin is loaded. Excuse me. So SBImage register loader is basically just how we inform SBImage of the existence of our loader. So that would be the struct here that we created with the function pointers that we defined up there. And then the other function that we need for the plugin is Finny, which is basically just how we call our cleanup. In this case, all we need to do is unregister our loader. If excuse me, if we needed to have some more persistent data within our plugin, we use this pdata argument to allocate and then pass around some kind of struct to store plugin configuration. But for image loaders, we don't usually need that because we're just, functionally acting on data and we don't need to preserve state. And then this define here is only needed if you would possibly be going to a static engine deployment. So that would be for something like an MCU where you're compiling into like a real-time operating system and you don't have things like DL open. Basically, if you don't know what that means, you don't have to worry about it. And then the meat of what the plugin is this gr plugin create func. So in order to set this up properly, you'll need to include managers.h from the SDK. So you'll have to memset the state struct, obviously, to be 0, and then setting the plugin version, giving it a name, registering your functions, and then this service number field on the plugin struct is how you control the priority with which plugins are loaded. So if you have, say you have an image format that your loader supports that's addressed by another image plugin, like say you have an optimized GIF loader, but you still want to use the soil image plugin that's shipped with Storyboard to load the other image formats, what you can do is you can set the service number to something higher than normal. And what that will do is, so you could just say service number normal +1, and then that will cause it to be loaded in the plugin loading loop before things that have service number normal, which is most Storyboard plugins. So if you do that, then your SB image loader will appear earlier in SB image's internal loader list. So if you try to load a GIF file, SB image will get a yes from your loader before it gets a yes from the soil loader. So your loader will be the one that ends up getting used. All right. So that's our code. And then the way that you would build it is, here's just a simple makefile example I'm using. So you'll need to include the header include directory, and you'll need to link against the libgre dot, it'll be A on Unix B platforms and .lib on Windowy platforms in order to get access to things like gr plugin create func and things like that. So, and I'm just using Clang to compile it. Pretty simple stuff. You'll need to compile with -shared to create a DLL, FPIC, because we're mixing static and dynamic libraries. All right, and then just to show you that it works, I'll do make clean, and then make. And then you can see over here, we've got our plugin DLL that we've created, or .zo because it's Linux. And then I'll just go over here to my terminal, and I will copy the .so that we just created into the plugins directory for my runtime. And then I'll just list the plugins of my runtime, and you can see it's there. And I will remove the, or I don't need to remove the soil plugin because I set up the service numbers. So I will just launch a quick demo app that I put together for this with some V's so that we can see what plugins we've got. And you can see here, we're loading a JPEG image using our custom image loader plugin. And yeah, it's that easy. If we want to get rid of it, all we have to do is remove it from the plugins directory. And yeah, so let's just go back to my presentation. So yeah, I mean, that's pretty much all you need to know to get up and running with image loaders. It's a pretty simple API, pretty easy to extend if you have SDK access. If you don't have SDK access, then you can work with the built-in image loaders to get a configuration that works well for you. And yeah, I think that's it. And I'm going to hand it back to Scott.
All right, so just some key takeaways. Definitely just to remind you that the plugins do provide you with that unique capability to fine tune what it is that you need and what it is that you don't need, really allowing you to kind of shrink down the overall kind of file size. That way, really allowing you to be kind of like have a better performance on your hardware. It is, in particular when it's maybe more tightly resourced hardware like a microcontroller. Also, again, like Jonah said, that if you do come across maybe there's a particular format type that you don't have, then definitely getting access to the SDK is one way to really allow you then to kind of, build out your own. So that way you can really kind of, again, fine tune the application to your specific unique needs. So again, just remind you that if you've not gone to the Help Center, there's a variety of different resources that are there to really help accelerate your learning when it comes to Storyboard, as well as it allows you to, also feel free to reach out and connect to us, whether it's you have a question, so you can easily pose it through the help desk itself. To kind of maybe there's a particular topic you want to learn a little bit more about. Maybe you do have maybe a suggestion for a future advanced user training session. Definitely reach out to us and let us know. And also, if you do maybe kind of in a future project, you do find that you're kind of maybe short on resources, definitely feel free to leverage our team of experts. As well as if this is the first time maybe you've attended one of these sessions, we ran it through 2020, so there are a variety of different advanced user training sessions that you can find on cranksoftware.com under our webinar section. So feel free to take a look at all those past sessions. We also post them to YouTube as well, so if you want to go to YouTube, you can check them out. And keep an eye open for future ones. We typically run them at the end of every month. However, next month in February, the session will be February 18th. So now's your chance to pose any questions that you have for us. And the first one is for Jonah. And Jonah, how would someone get their hands on the SDK?
So like I said, it would be something that you purchase in addition to or as part of your Storyboard licensing. And what that gets you access to is just a bunch of the headers that we use to extend the engine ourselves, to write plugins, to write image loaders, and other things like that. So yeah, it's something that you have to purchase as a part of your licensing.
Okay, so definitely, so if it's something that they haven't purchased up front, it's definitely something that you can reach out to us after the fact if it is something that you do need, and you can get access to it after the fact as well. Not something you had to purchase up front, correct?
Absolutely.
Perfect. When it comes to plugins, are there other plugins that can be leveraged or removed beyond just image plugins?
Yeah, absolutely. So if you just kind of look through the plugin directory, most of the names are pretty self-explanatory. So there are plugins that control things like playing audio, using touch screens. There's render extensions that you may not be using, like the canvas or the polygon even. So really anything that you see in there that you don't think you're using as part of your application, I mean, just take it out and see if it breaks, or failing that, you can always contact the support team and have them help you figure out sort of a minimal configuration for your deployment case.
Perfect. So that seems to be the only two questions that we have right now. Again, it's your chance to ask any questions, or feel free to always share with us maybe a future topic you'd like to hear. And also, if you didn't get a chance to pose it right now, you can always ask it after the fact on cranksoftware.com within our support queue. All right. So with that being said, I want to thank you very much for your time today, and take care. And we hope to see you in our next session. Thanks.